Namaskaram everyone, welcome back to the 52nd episode of our Master Unreal series. And in the last episode, I showed you state trees basics. And now in this video, we are going to take one more step into state trees where I'm going to show you how you can deal with the transitions, how you can deal and utilize parallel task instead of using Evaluator or a global task. And along with this, we will explore the debugger to understand how to debug the state tree. And as we proceed, I'll also show you how you can make your state trees modular and scalable. So instead of clubbing everything into a one state tree, we'll also see how you can combine multiple state trees. So if you haven't seen the last episodes of AI, then I highly recommend you check them out because everything is connected. So without wasting any time, let's get started. All right, so we are in the editor now. This is what we did last time in the state tree episode. Now let's advance it and complete this travel behavior using the state tree. In this, I would like to ask you a quick question. In the last episode, we created this evaluator to keep the track of the escort, right? And I told you the evaluator should only use the parameters and context to construct the conditions and fetch the data that is required by the state tree. Now ask yourself a question. You want to track whether a companion went out of the range or not because you want to transition to call companion so that you can play the animation or trigger a dialogue, whatever. So you only want to keep track of the companion if you are in this state, right? If you are in some other state, would you like to do that? No. As of now, there is no such situation where you want to keep track of the companion except when you are moving towards the destination, the leader that is leading the escort, which is controlled by the state tree. So if you just want to track companion for this particular state, then why use an evaluator? Evaluators should be used so that the conditions and the data can be used in more than one state, at least more than one state. If that is not happening, then it is better to use tasks. I told you when a state becomes active, all the tasks that are added in that state will become active and will be executed concurrently, parallelly. So that means this move to will work and I'll add another task that will keep track of companion. As soon as the track companion detects any companion goes out of the range, I can exit this state and go to call companion. Simple. You don't have to track continuously. So in such cases, when you only want to share the data with one state, it's better to use parallel tasks instead of evaluator. I will create a new task and I will name it STT underscore find out of range companion. Okay. Now, once the state that contains this task activates, we would like to set timer by event and we would like to constantly check every 0.2 seconds whether a companion went out of the range or not. So we'll say track companions. Now many of you will say, why not use tick? The trigger count of tick is always greater than the timer. Okay, so you can specify higher duration when you fire this event. In this particular case, we do not care if we are facing some delay. Let's say if you are notified 0.2 seconds late, it's okay, you can wait. In some cases, it's okay to have a delay. So it's better to avoid tick in this case and use timer because we can afford the delay. Okay, so we will set the timer and we will fire the event, and we will also promote this to variable so that we can clear out this timer when the state ends. So we'll say exit state and clear and invalidate timer by handle. Okay, so now we need to set up the logic. We have already coded in the behavior tree, so we will copy it from there. I'll go to AI behavior trees, track escort, and this is the logic where we are tracking the companions. So copy this false flow and paste it here. And we have to create this function. So create matching function, confirm. And now we can connect this. Great. So find out of range companion is there. We need to provide the character and we also need the controller. So what I'll do, I'll get the AI controller, or I'll just say controller, and I'll change this to AIC default. And I know this is part of my context. So I'll give it a category of context. Now, once you have that, you can connect it. Second, we want to pass the character as well. So we'll say get controlled pawn and we will connect it. And now we need to implement this function, which is also something we implemented. So what we will do, we will copy this entire implementation and we will paste it here. You can delete this return node, which is connected with this function declaration or call. And now we need to provide the source. So source is already here, companion is here, and now we need the escort data. So let's create it. And this is part of input. So we will say input, compile. It's okay if you are getting the errors. Let's have a look. All right, so we have to create the variables. Let's create this variable that is out of range companion. Then we do not need any blackboard thing, but we have to share this out of range companion so that call companion can track the distance. So I'll come to this in a minute, but before that, let's update other things. I'll say out of range companion, which is good. And now I have to update whether a companion left behind, because if we go to escort, we will trigger a transition when this task finds a companion that is left behind. We will go here and we will just remove this and we will say B is companion left behind, and we will set it to boolean and we will set it to true. So we will not stop the movement here. The reason being, if we stop the movement, then in the move towards target destination, the move to will be interrupted and it will result into a transition because this has been interrupted. And by the time, there is a possibility that this goes to transition and transition does not find this variable updated. So first we will update this variable, then we will stop the movement so that transition can have the correct value. So first we will put it, so we will put this first and then we'll go for stop movement. And once the movement is stopped, we would like to finish the task with a success. We will say that we have found the out of range companion. Great. So let's compile. And now I have to expose this as my output so that it is available for display in the state 3, like you can see here. Now what we are going to do, we are going to add a transition. Now here's a catch. If the move to task is interrupted first, and let's say this triggers the transition, then this will be considered as a failed state. If this task triggered the transition, it will be considered as a success, because you see you marked finished task succeeded. So that means it found a companion, and this will say on state failed because it was interrupted. So the clash can happen due to any reason which we cannot say for sure. So what we will do, we will not consider the success first. First we will reposition our transition. We will say if the state is completed, doesn't matter if it's a success or failure, I would like to transition to call companion if is companion left behind is set to true. So what we will do, we will say if is companion left behind is true, then go to this state, otherwise it's a success. So if this task completes successfully, then this will be true. And if this one completes successfully, it's a success. But if it's failure, that means the companion went out of the range. So far, this is the situation. Later on, we will advance, so there will be more rules. So we will transition to call companion, and now the call companion has to make sure that the separated companion value is set. If it is not set, then that's a problem for us. So what we will say, I would like to check, let's add a condition first, that the object is valid. Which object? That is our parameters separated companion. If this is valid, then we will allow the entry. Otherwise, we will head back towards the target destination. So if the state fails, I would like to go again to move towards target destination. And if it's a success, then we will say go inside. So for this, we will add a state and we will say wave, and we will put it inside it by dragging it, and then we will add another state, that is stare. Okay, these are the two we talked about, and first we will process the wave, then we will process the stare. And now the call companion, on success we will go to wave. Now before we go inside, we would like to set the focus on the player that went out of the range. So what we will do, we will create a new task, that is stt underscore set focus. Now remember, whenever you assign a category to a variable, that means that variable has to be bound to some property. But if you do not categorize it, then it can have a default value. I'll show you. So here we would like to enter. So I want to access the controller so that I can set the focus. I'll set it AIC default and I'll say set focus and I'll promote this to variable and I'll say focus on. Now, if I do not pass this focus on, that means I would like to clear the focus. We cannot create another task just for this. It should be self-understood by the function. So what we'll do, we will say that if the focus on is valid, that means it would like to set the focus. Let's remove it and plug this one here. And if it is not valid, then we will say that it wants to clear the focus. Now here's a catch. If I compile save all and controller is coming from context and now leave the focus on right now. Now if I go in the call companion, add the set focus and I bind the AI controller. Now I want to provide the actor here. So if I go to set focus and I consider this as our input, compile, then I have to bind. If I do not bind, it will show me the error. Now this is not something we want. What we are saying is that the companion that we are trying to target can be invalid. That means it is no longer there. So we want to pass none value. So that is not possible if you assign a category. Category means it has to be binded. Okay. So instead of assigning it a category, we will put it back to default and I'll say instance editable. So my bad, finish task success, compile, go back to Escort and now you can see you can provide none and you can also bind to it. So in this case, we would like to bind because we know it is a valid. So we would like to focus on it. Okay. So if you come across a situation where you want to provide a none value, then using a category can be difficult. Now, other option is like you set the none value here, but I don't think that is needed because you have to again get it, then set it. That's not something we want. So this is an escape way out of such situations. So if this object, the separated companion is valid, then we would like to continue and execute the task, which will be considered as a success eventually, and then we will transition to wave. Now, when you transition to wave, I want to play an animation because you went out of the range. So I'll create a new task and I will call this STT underscore play montage. Save. I'll get my character and I will call it actor object reference and I'll enter the state. What I will do, I need the skeletal mesh. So get skeletal mesh, plug it here. And now I would like to play animation montage and the animation is waving. You can also promote this to variable and you can say it as input, right? And once you do that, when the completion happen, you can say finish task. And if it is interrupted, then also we would like to finish the task with a false success. Great. Now character is our context. So we will put context category, compile, go back to escort tree and now you can add this task here, play montage, actor, animation montage, and now we have to provide the value. So here what we can do, since this parameter is supposed to be used here, I can add a parameter, call this anim montage object reference and I can select waving and I'll rename this to call companion and more precise am call companion. Okay. Now why I created this parameter here, because later this animation can be changed based on the character that is possessed by this state tree, right? Maybe that character has different style of calling the companion. So such values should be in the global parameters so that you can update them externally. I will tell you later, but for now we will bind to it. So go in the wave, parameters, am call companion. Okay, compile and save all. Great. So once this play animation is done, we would like to check if you are still out of the range. So remember, there are two situations happening, success or fail. In both the cases, we would like to check whether you are still out of the range or not. Because if you are out of the range, then we will again wave at you. So select the wave, and regardless of success or failure, we would like to check the distance compare. Use this node this time. And here you can provide the source, target, and the distance up to which you want to check. And you can also apply your operator. So I'll show you. Instead of providing a vector, we would like to get the actor location. So use this function that comes inbuilt. And now if you expand these two, you can provide the actors. So first, source is our character. So actor, and the target is the separated companion. Once the distance is calculated, we would like to check if you are outside the companion range. So if you are outside, that means if the distance is greater than the escort data acceptable companion range, then we have to wave at you again. And if that is not the case, then it means you came back. So if you came back, then we would like to go for stare, because you just came within the acceptable range. You did not come within the resumable range. So we'll just say on state completed, stare. So compile, save all. Now we will go to stare, and now I will add a delay task, which means I just have to stare. Because remember, you already set the focus when you entered in the state. So you are still focusing the player, and now all we need to do is just create delay till you come back to the resumable range. So I'll say let's wait for 0.3 seconds. Okay, no deviation, exactly this time. And I would like to add the transition, and I will say once the delay is completed, I would like to go back towards the destination if distance compare again, actor location, and source is our actor, target is our separated companion, and the distance this time is the resumable range. So if it is less or equal, that means if the companion came back within the resumable range, then we would like to resume the escort. Otherwise, we would like to keep staring unless you go out of the range again. Let's say you came back in the acceptable range and then again you went back. So in that case, we would like to wave at you. So we have to transition to wave. So there are two more rules that are required. Another situation is we will go back to wave if the distance between the player. So let's get the actor location, and we will say the source is our actor, target is our separated companion. If that is greater than the acceptable companion range, if that happens, then we would like to go back at waving at you. And if that is not the case, that means you are still within the circle. Neither you have came in the resumable now, nor you have gone out of the acceptable range. So we will continue to stare at you. So we will say stare. So this is the order. File and save all. Now if we go move towards the target destination, we are still focusing on the player. We have to clear this focus. So we'll create another state that clears the focus for us. So I'll say clear focus, and I will put this inside the call companion, and I will transition to clear focus instead of moving towards the target destination. So what I'll do, I'll change this to clear focus, and let's rename it to better. Companion came back. Okay, so companion came back to resumable range. So we would like to transition towards the target destination state. And before doing this, we would like to clear the focus. So we will get our AI controller, and setting it to none means you want to clear. Okay, makes sense. So I'll compile and save all. Let's test it out. Go back. You see, it is waving at us, and we are still not in the acceptable range. So it will wave at us again. Now, if we go back to acceptable but not in resumable, then you see it is just staring at us. Okay. Now, if I go near, the transition did not happen. So let's see. And after revising everything, if you still observe this kind of behavior, that means it's an issue with the state tree. I think it is still under development and there are major updates that are happening in each version. So if we reopen this project in 5.6, so what I'm going to do is migrate this project into 5.6. So I'll close this. So I'll open Epic and I would like to reopen this project in 5.6. So what I'll do, I'll just launch 5.6 version and you will find this project browser. Select the third person game project, open a copy. When you will open a copy, it will create a new project in 5.6. I'll say no. And see, we have not made any change in our program or in our code. What I'll do, I'll just go to edit, preferences, and I'll increase the scale for you guys. And I'll go to third person maps level 1. Okay, no change. We'll just play from here. No change in the state tree. If I touch the box, you see there is no issue. The task is completed successfully. It is calling us, and if we go near, it will resume the escort. But you see, now it is calling that companion. If I press Shift F1 and detach my controller, and if I bring that player, you will see it will start moving towards the escort. So this is something with the state trees. I personally don't know. Before even starting, I mentioned this, like the state tree is in development. I think we should wait more. That's the reason I have been delaying the episodes. So considering this escort tree, now we will make it part of a bigger tree that is our travel tree. So I'm going to show you how you can connect multiple state trees. We'll go for AI state tree AI component, and I will call this travel. st_travel. Open this up. Inside it, first of all, we need to specify the classes. So this one is AI BP AI default, which is our character, AI character, and this is AIC default. Okay. Now if I compile and I'll add two state, this one is for escort, this one is for follow. Okay. Now I'll check in the escort, I'll add a condition and I will check enum compare, and in this I will go in my actor and I will access my travel mode. So if this travel mode is escort, I will follow this state. If it is not, then it will go to follow. So we will put a condition here, enum compare. If this travel mode in actor is follow, then follow the follow tree. Okay, now these are states, but we would like to get them converted into linked asset so that you can provide the tree. So for escort, you can select this escort tree and you can provide it. Now you see you can update the parameter of animation, which is by default set to am underscore waving, which was our animation. So I will save all, and now I will need the follow tree. So what we will do, we will create another state tree and I will call this st_follow. I'll open this up and I will add a state that is follow. Second, I will add a state of hold. Okay, so in the follow, we will add a task that is our move to. In this, I will provide a AI controller. I need to access the follow data. So I'll create an evaluator. So I have to search for a blueprint class, go for evaluator. We will expand this escort and follow more. So I'm going to use evaluator again, and I will call this st_follow. Oh, it should be ste_follow data. Okay. Open this up. Once you open it up, go on tree start, and now you would like to fetch the data. So first we need the character. That is our AI default. So first I will get the component by class. That is our travel behavior. Then I will get the follow data. Okay. I'll promote this to variable and I'll connect it here and I will outsource it. So character comes from context. Follow data comes under the output category. Okay. So compile, save all, go to follow, and now you can add this evaluator and you can provide the AI defaults. Okay, we did not change in the follow state tree. I'll change this to AIC default and I'll change this one to BP AI default, and now I can connect it. Okay, compile and save all. Now we can access the target actor. So from follow data, the leader, and the acceptable radius, st follow data, acceptable success range. Okay, and if the state completes, we would like to go to hold, and from hold we would like to add a very small delay, let's say of 0.15 seconds, and then we would like to transition back to follow. Right, so compile and save all. I think we should also go in Escort and go to target destination, and we should change this acceptable radius to track escort, escort data, acceptable success range. Okay, compile, save all, and go back to travel, and now you can connect the linked asset, that is your st follow. So compile, save all, and now we can go back to our blueprints, AI default, and here you were calling this for escort. Now you will also call this for follow. And we will also check our AIC default. We were plugging the escort here. So instead of escort, we will plug the travel. Okay, so that it is generic. And now if I play and touch this, you see it is now following. We go back, it calls us, and that guy stops there. If we go near, it goes there. Okay, so this is how we travel. And now under the escort, if the state tree succeeds, that means the escort is over, which will happen only if you allow it to, of course. So if you check your code, here you are selecting this state. You are calling the tree succeeded only when you successfully reach to the target destination. So we will go back to travel, and here we will say on state succeeded, that means this particular one, we would like to consider the travel tree succeed. In case of follow, we would like to do the same thing. If this tree succeeds, then we will say tree succeeded. Okay, so save all. And now here's a catch. We have to notify the mission manager because that is what going to decide whether the escort is over or not. So we will create another state and we will say escort over. And here in the escort over, we will put a condition. We will say the distance compare. We will say first we would like to get the actor location. Now you see you can use both different ways. I will put the actor first, and here in this I will put the target destination. If you have reached within the successful range, which is from the escort data, acceptable success range, we'll say less or equal. If that happens, then we consider the escort is over. So we will fire a task that will notify everyone. So we will go in new task and we will go for state tree task blueprint base. We will say stt notify escort over. Okay, and we will save it. Inside this, we will go for enter state and we will access the escort data. So let's get the escort behavior. We will say on escort over, we will call it. And once we call it, we will finish the task success. We will go back to escort, and here once this state is successful, we would like to succeed the tree. Otherwise, we will not. And we have to add a task. So let's add the notify escort over. And I'll expose this into input category. Compile. State tree, we can bind this escort data. Now, in case some of you have linked it to another state tree, you might have to bind the parameters again, like in the AI controller. I have to provide the target destination, acceptable radius. Okay. Here as well. Okay, we also have to bind it with the separated companion, escort data, and we are all set. If we compile and save all, now we will not succeed the tree in the move towards transition. Instead, we will transition to escort over, which means it will end the tree. So compile and save all. And we will also check the follow, and the follow behavior will not be ended or be notified. This is something which will happen based on the external situation. So it will keep running. We will not consider it as a success or failure. And we can go back to our mission 1 and we binded the escort over here. We will unbind it, then we will wait for 1 second and then we will destroy the soldiers. Now you see, if I play the game, I'm not completing the escort. So sometimes these situations can happen and I want you to introduce to this debugger. Now you can go inside window and you can select this debugger and it will appear on the screen. But instead of playing it from here, you should always play it from the main tree, that is your travel, because the logs will come here because the escort is part of this bigger tree. So we will play it from here and we will touch this box and you see there was a log, and if I go at the target destination, nothing happened and I got this. There is a possibility you might get little more, so adjust this slider to find out the exact position. And moreover, this one is your follow controller and this one is your escort execution. So if you drag this slider a little bit here, this is when you reach the target destination. Let's observe. You reached towards the target destination. Now it was a success. Since it was a success, let me expand this. You made the transitions active and here the on state completed was triggered because completed means either it's a success or failure, and then it checked the condition whether it was because of the companion that went out of the range. So it was not the case, so this transition failed and it went to the second one, that is on state succeeded, go to escort over. Once it reached to escort over, you see it was trying to check this condition here and it failed, and since it failed it did not publish the event. So if I expand, you see the comparison was 234 is equals to 200. So we did not want that and it was supposed to be less or equal, but that is not the point. The point is there is a delta of 34 meters which we have to adjust on our own because it's not going to be 100% precise every time. So the acceptable radius of move to is different than the distance comparison. So we'll just add a small delta of 45. So what I'll do, I'll go in escort. In the conditions, I can say math float add whatever the distance you want to give us, that is acceptable success range. We'll just add 45 into it just to cover a little more area. Compile and save all. And if you play now, the escort is over and the guys disappeared. Okay. So that's it for this episode. I hope you enjoyed it. This is the second deep dive into the state trees. In further episode, we will advance it more further, where your allies or enemies can crouch, they can carry equipments, and they can wait for the clearance, how you can use a spline. So there are a lot of things that you can do now, but this is one of my ways to implement the traveling behavior of your character. So in the next episode, we will go further into NPCs. We will prepare our merchant shop. There are more use cases that we are going to cover. For example, your allies can be part of an escort and you are a sniper that is sitting behind or somewhere on the tower where you provide them the cover. You will use splines, and based on the position of spline, you will hold your escort for a moment or for a while till you clear out the target. So that gameplay mechanics we are going to cover with the help of state tree and our systems that we have built. So stay tuned. We are going to do a lot more than this simple travel. And if you like my work and you want to support me on Patreon, the link is in description. Please have a word with me before you buy any membership. So like the video, share it with your friends, subscribe to the channel, and I'll see you in the next one. Bye.